Okay, so in the last class we discussed about the domain and range. So there are some confusing cases like relation on the singleton set. What are the singleton set? In the previous classes we discussed that singleton sets having the single element, and suppose they are equal, both sets are equal, then R is defined on the set itself, right? So relation is on himself, like A cross A is the relation. So whatever this relation, this is going to belongs to the Cartesian product of the A itself, right? Or you can say A cross B, but here B is equivalent to the A, so it doesn't matter, it is A cross A. So in that case the domain will be the first component of the pair and the range will be the second component of the pair. Definitely they are coming the equal, but we have to write the domain and range accordingly, all the first elements and all the second elements. Empty relations. If we have an empty set, right? If we have an empty sets or these parentheses, nothing we have. Suppose this relation we have nothing, right? This can also be written as R is equals to 5. So when we are doing the relation with the empty set with the empty set, right, then their domain is also empty set and the range is also empty set or null set, you can say. Okay, so this is just the basic that people get confused that what will happen to with the relations when we have the empty sets and empty relations. So no problem, their domain is also empty and the range is also empty. Okay, now move to the function. That's our topic of today's session. So function from a set A to a set B is rule or mapping that assign each element exactly one element of the B. So first understand, function is nothing but simply a relation, right? A relation, a well-defined rule that mapping the two sets. Suppose we have a set A and set B, so we are mapping them, we are relating them, where what we will see that we assign each element of A, set A is there, suppose, and set B is there. Okay, so A and B are related to a rule, and that rule is our function, right? So each element, like all the elements in the A, suppose we have A, so all the elements in the A are going to have the one element in the B, right? The adjoint element of B is called the image of the function, and this is our pre-image and this is our image. Okay, so pre-image and image. So you can simply say, suppose we have a set A, set B, they are defined under a rule F. So all the elements, suppose here A, B, C, and all the elements here also, suppose A, B, C, D, something A1, B1, C1, something, you can put the elements here, and this A is related to A, right? B is related to also A, but it's not happen that A is going to related to B. What is saying that exactly one element of B, right? Exactly one element of B. So this A element must have related to one of the element. Okay. The second adjoint element B is called the image. So this is our image and this is our pre-image, right? The image and the pre-image. So function f A to B is a subset of the Cartesian product A cross B such that for every element of A belongs to A, there exists some B belongs to B such that A and B belongs to the function. Definitely function existing there, therefore the element A is there and therefore the element B is there. Okay, and suppose there is a element A B1 that belongs to the function and A B2 that also belongs to the function, and B1 is equals to B2, then uniqueness. This is the uniqueness of the function if B1 becomes equals to the B2, right? Every element in A must be mapped to exactly one element in the B. As I told you that every element of A must be mapped only element in B, exactly one element in B. Know the two element of the A, right, can map to the one. What that mean? A must be mapped to exactly one element in the B. So they are talking about the A. See, remember, A can be related to A1, A can be related to B2. Is this the case? Now, the case is here A is related to one element, B is related to one element, C is related to one element, and they all can relate to single element, but one A cannot relate to the two element. Clear? Okay, so no element in A will be left unmapped, and no element of A can be mapped to one or more than one element in the B. Right? So here A cannot be mapped to the both element. Clear? So function focuses on the mathematical definition where each input has exactly one output. Emphasizes the process of rule that connects elements of the domain to the elements of the codomain. What are the important properties if we will look? Domain function is the set of all possible inputs. So A, B, so all the A will be the domain, right? Codomain, set of all possible outputs. Remember here is talking about all possible outputs. But what will be the output? How they are related, it depends on the function itself. So note that not all elements of B need to be actual output of A. That's why the range concepts coming, unless the range will be equals to domain. There are maybe cases the range equals to domain, but may not be also. So range of a function is the set of all actual output of A, formally range equals to F, where B belongs to B, then exist A belongs to A, such that function F equals to B. Right? When we are putting an element from the domain, we are getting output B, that is our range. Range is always subset of the codomain. Okay. See here example. We have a set A and B, they are defined by a function F. So if we are putting here F1, because all the A are domain, A is domain, right? And we are taking the elements from the domain, that is also input. So we are taking the elements from the input in our function. Suppose the first element 1, so we are getting output 4. Similarly, we are taking the 2, we are getting output 5, we are taking the 3. So whatever the outputs, they are making the set B, right? So this is our range. What? No, this is our codomain. The second part, the set B is always the codomain. What are the all possible output we will see? That 4, 5, 5 coming. So even after putting all the elements of A, we are getting output 4 and 5 only. So 4 and 5 are our range, but codomain is 4, 5, 6. Clear? Okay.